Okay, so the first thing we're going to cover is numerical integration, and we'll probably have a couple of lectures on this. First, we're going to talk about numerical integration for tabulated data. Okay, this is where we have exactly what I said, tabulated data. So we have a table of values, and we can just look up all the different values, and we need to be able from that to find the integral when the function is represented by a table of values. That's a lot of times the case where we're actually taking the data and we don't have access to this underlying function. And then there's another situation where we might have a known function, but but it may be hard to analytically take the integral of, and so we may want to use some other method. So the first thing we're going to talk about then is what we do for when we have tabulated data. And I'll just point out, if you have tabulated data, it will work for any known function, and because if you can evaluate the function anywhere, you could create a table of values. So these methods for tabulated data are more general and applicable to the case of the known function. However, the inverse is not true when you have just a known function and you can evaluate it wherever you want. You can't necessarily you can't necessarily apply those same methods that are used there to tabulated data, and we'll see that more as we go on. But just again, in the way of an overview, we're going to look at what's called NewtonCotes formulas, and that's going to constitute the majority of this lecture series 6.1. In particular, we'll look at NewtonCotes integration formulas for open and closed situations. We'll also look at the NewtonCotes formulas for open and closed, also evenly versus unevenly spaced. What do we do when we have unevenly spaced, and what do we do when we have evenly spaced data? And then the other thing is we'll be able to apply these methods possibly into multi-dimensions. So just like in the previous chapters, we've generalized. We've started with a simple, like when we introduced regression, we started with a simple constant, fitting a constant, and then we fit a line, and then we fit a quadratic. So we're just doing simple polynomials, and then we generalized that to multiple dimensions. We generalized it to higher order. We generalized it in several different ways. So the same thing we're going to do. We're going to introduce the NewtonCotes formulas. We're going to move them into higher order, and then we'll also move them into multiple dimensions. Then the next thing we're going to do is look at the known functions and the methods used for those. But let's get started then in looking at the methods that are suitable for tabulated data.